It is acting on a body which is at rest. Andre, if I know the substitution properly, not more than 2 minutes to solve such problems. You remember y minus u. Previous session I have told bouncing is happening in opposite direction. Value of velocity of the smaller mass is 2 meters per second. Hello students, this is SD Sir, yet again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. What is that I have got in store for you all today? Some more interesting numericals on the chapter Laws of Motion. I expect you have gone through the previous sessions. You are thorough with the equations, concepts, and you have all geared up for today's session. The first problem. The problem says there is a force of 80 Newton acting on a body which is at rest. Force of 80 Newton acting on a body which is at rest for 2 seconds, and it imparts a velocity of 20 meters per second. It acts for a time interval of 2 seconds, and it is imparting to give a velocity of 20 meters per second. Calculate the mass of the body. Also calculate the distance traveled by the body in 2 seconds. As we usually do, first what is that? Collect the data. How much is the force? Force is 80 Newton. It is acting on a body which is at rest. Andre, initial velocity of the body is 0. And it acts for a time interval of 2 seconds. So time interval is 2 seconds. And gives a velocity of 20 meters per second. So what is that? First I have to calculate the mass of the body. Analyze the data. Force is given. What else I require to calculate mass? Acceleration of the body. So my first task here is to calculate the acceleration. So again, I use the equation V equals U plus AT. Because I need acceleration. Velocity is 20. Time interval is 2. 20 is 2 times A, or A is 10 meters per second square. Notice? Very simple. So it is 10 meters per second square. So once I know acceleration. How do I calculate mass? Newton's second law. Come on, Mr. Newton, help us. Force is mass into acceleration. Mass is F by A, AT by 10, which is 8 kgs. Finally, distance traveled by the body. We have S equals UT plus half AT square. Yes, 0 into T plus half T square is 2 square. So this is 5 into 4, 20 meters. If I know the equations by heart, if I know the substitution properly, not more than 2 minutes to solve such problems. The next one, interesting one. A ball of mass 0.2 kg moving with a velocity of 2 meters per second strikes a wall normally. It is striking a wall normally and bounces back with the same speed. A problem again on bouncing of a body. If the time of contact between the ball and the wall is 0.05 seconds, what is the average force exerted by the wall? The moment I say force, and when I read the problem, eventually I understand mass is given. So what else I require here to calculate force? Acceleration. What is the concept here with which I have to calculate acceleration? Bouncing back of the ball, same speed. So here I say acceleration is change in velocity divided by time. Wherever you have bouncing systems, you can use this concept to calculate acceleration, which is change in velocity divided by time. Or A is V minus U by T. You remember y minus u. Previous session I have told bouncing is happening in opposite direction. So this is 2 minus 2 divided by 0.005, and on simplification here it turns out to be 800 meter per second square. Acceleration is calculated. Mass is known. So what is force equal to? So 0.15 into 800, which is equal to 160 Newton. See? Calculate acceleration. Since bouncing system use this concept, Newton's second law, I arrive at the expression for force. Next one. A body of mass 7 kg moving with a velocity of 2 meters per second explodes into two parts of mass 4 kg and 3 kg. So, there is a body whose initial mass is 7 kg. So, initial mass means to say the mass before collision. Now it explodes and that mass is broken down into two fragments. One fragment, one part has mass 4 kg and the other has mass 3 kg. The greater of the two parts moves in the same direction with a velocity 5 meters per second. I have to find the magnitude and direction of the velocity of the smaller part. So now here we observe the greater of the two parts, andre the fragment which has more mass is moving in the same direction with a velocity of 5 meters per second. That means I have to find the magnitude and direction of the velocity of the smaller part. Now, before collision, very important, before collision, the entire body is moving with a speed 2 meters per second. So U is 2 meters per second. U2 is 2 meters per second. Now it is exploding, broken into two fragments. One of the fragments has mass 4 kg and the other one has mass 3 kg. Now the body with higher mass, greater mass after collision moves with a velocity 5 meters per second. I have to find the velocity of the fragment with lower mass. We will go over to the law of conservation of momentum. What did we understand from the law of conservation of momentum? Sum of initial momentum m1 u1 plus m2 u2 should be equal to the sum of final momentum. This is explicitly the law of conservation of momentum, from which I have to calculate V2, that's all. Now substitute. This is 4 into 2 plus 3 into 2. M1 after collision, mass of the higher fragment, 4 into 5 plus 3 times V2. This is 8 plus 6 is 20 plus 14 is 20 plus V2. V2 will be equal to minus 8 plus 6 is 20 plus V2. So, 3 times V2. So, minus 2 meter per second. So, magnitude of value of velocity of the smaller mass is 2 meter per second. What is that negative sign indicating? It moves in a direction opposite to the higher mass. That's all. The smaller fragment and the larger fragment, they move in opposite directions. The next one. A machine gun fires 200 bullets per minute with a velocity of 60 meter per second. If the mass of each bullet is 0.02 kg, calculate the power of the gun. Now, the concept here is, first I will calculate the work done by 200 bullets in 1 second, where we know work done is change in kinetic energy. Why I am using this concept? Because I know power is work done by time. So this is work done is change in kinetic energy. So work done is kinetic energy is half mv square. But this into 200. Because 200 bullets are shot. Mass of each bullet is 0.02 kg. So this is half into 0.02 into 60 square, which turns out to be, so the work done is 7,200 joules. Now power is work by time. 7,200 by 60. So this turns out to be 120 watts. So see, various concepts. Just figure out the concepts. Substitution and calculation is very, very easy. Again, my next session will reflect few more problems from laws of motion. Until then, have a nice time. Thank you.